All right, so a couple minutes late on the recording, but here's, we're doing a lab today. You guys have got those launchers that I showed you guys how to use yesterday. And there's different setups, different possible tables to pick from depending on which way you want to go with this. All right, so I gave you guys this page with these 5 structured questions on it. I said on the opposite side, write your name on your paper and pick one of these 2 questions. I'm helping you guys narrow this down a bit. You can either pick what is the blast speed of the launcher, or you could pick the question, what is the optimal angle? And you have to specify, so let's say like from the horizontal. To send the ball the furthest, I would say distance, but since we're in physics, I'll say horizontal displacement. Okay. Right. So pick one of those. Right. Now, depending on which one of those you choose, you could have one of a number of different setups. Right. So again, just to guide you guys along a little bit. Right. Probably the most straightforward thing you could do is we're about to head up to the stairs, and there's a huge ledge, right? So if you do this first setup, see, you could aim the launcher straight horizontal. It's going to fall some height. It's going to go some distance. And if you get those 2 numbers, the height and the distance, and you know gravity, you know the gravity field, then couldn't you have enough information lying around where you could go back and figure out the blast speed? Right? So this would be a table that could possibly go with that. Just do a few trials, maybe figure out how to take an average somewhere, something like that. Right. I should tell you guys that the philosophy behind what we're doing here versus the philosophy of the last lab, with the carbon ramp lab, is actually two different approaches. With the carbon ramp lab, remember you guys were rolling the cars down the incline? We were approaching that from the point of view of we didn't know how physics worked, and we were discovering equations for ourselves. Okay. Now this lab is the opposite. This one, you know all the equations. Here's some of them that I wrote for my honors class. I said, hey, these could possibly be useful. Maybe not all of them, but any of them, depending on what your setup is. And you know the equations. You're allowed to use the equations. You know gravity is about 10 meters per second squared. So can you utilize that knowledge to figure out something like what is the blast speed or what is the optimal angle for distance? Okay. This one right below it is a different setup. Maybe you could aim it straight up and then say, hey, what height does it go to? You could figure it out from there. Right? There's going to be some maximum height based on that blast speed. You can back calculate what that is. And then these 2 on the right look like the same setup. I mean, they're the same. They're the same setup. The table's a little bit different because they're designed to answer different questions. You could answer what is the blast speed by doing this setup. Now, it's probably the most difficult way to go about this lab, but you could do it. Okay. But you would want this setup to answer the question, what is the optimal angle to send it for the distance? And if you did have that question specifically, then you would want to treat the angle as an independent variable and probably want a table that's more than 4 trials, although that's all I can say on this paper, but probably do at least 5 if you were doing the optimal angle one, right? Now, one of the things you guys are going to need is the mass of the ball. I mean, it's just probably good practice to know what that is. I went ahead and measured it ahead of time. I got 10 grams, which is also called 0.01 kilograms, so 0.010 kilograms. There is a triple balance beam up here on this front desk if you wanted to test that for yourselves, but that's the mass of the yellow ball, so I'm giving that to you guys. And then before we head out, do you guys remember these 5 questions on the front? While we're out there and you guys are making your measurements, getting calculations, on the side, see if you can multitask and answer these questions. So say, what is the question? Just copy that from, well, I narrowed it down, told you 1 of 2 questions. Okay. Your measuring tools. What measuring tools are you using? I gave you guys a meter stick. You do have protractors on your desk that could possibly be useful. You could use a stopwatch function on your phone. I don't think that's the best way to go about this lab, but that is one way you could go about it. So think about what tools you're using. Data gathering procedure. Say, remember how the last one went? Remember it was just a small handful of steps? Say, I did this, right? You explain the setup very briefly. Then you say, I use this tool to measure this, use this tool to measure this. Just how are you getting your data? Okay. The next section is, how are you going to analyze that data? Now, for the carbon ramp lab, we went to a graph. We plotted some points and then linearized it. Right? That was a graph bridge. This is different. This is, you're allowed to use equations. These are some of them. Right? These are possibly useful. Right? So point to specific equation you should use, right? And then your conclusion is going to be the answer to your question. Either what is the velocity or what's the optimal angle. Now, the last 10 minutes of class, I do have, I made an AP style rubric to grade this. So the last 10 minutes of class, we'll be back in here. I'll have you guys grade yourselves. Okay? Right. Any questions about what's going on? How's it going to work? All right. You guys ready to head out to the stairwell? Stop this recording, and we're headed outside.